Hi, welcome back. We're going to do another screencast about using keras and R to demonstrate overfitting in neural networks. And so yeah, in the first tutorial in this series, I wrote this code where you have a for loop over the hidden units. You have a bunch of different sizes of neural networks with one hidden layer and different numbers of hidden units in each network. We fit the model in the last one with just 2 hidden units, and now let's try to do one of the other ones. So how about hidden units I equals 10, so this is going to be the last one. Here now the hidden units number is 1024, and so if we do the model fitting again, when we have more hidden units, our model has a greater capacity. It takes a little bit longer to train, but what we're going to see is that it's going to give us, probably these typical learning curves where the train accuracy is always going down, whereas the validation accuracy should go down and then go back up again after a certain number of iterations. So let's see if that's happening. Alright, I said we're going to go for 100 epochs. So we're going to wait for a little bit, but already by just looking at the printed output, you can see that the train loss is kind of is going down a little bit still, It was up here, it was like around 90, 91, 0 and 91, going down to 92, 90, going up. Oh, sorry, that's the accuracy, right? So the loss here is what should be going down. So it starts at 23, 22, 21, 20, 19. So it seems to be steadily going down, the train loss. The validation loss seems to be fluctuating a bit more, which is to be expected. Anyway, so now we're done. So let's plot that result and see what it looks like. So here's what the result looks like. And again, in the top panel, we have the train loss in orange, and we have the validation loss in blue. So what we see is that the train loss is consistently going down, but validation loss seems to, start out, high, hovering around 0.6, 0.7, and then getting, it goes down to some local minimum around here, I guess like around 20 epochs, of about 0.35 or so, and it seems to like go up a little bit after that. So yeah, so that's more or less typical kind of learning curve. So that says is that, after we get to about here in this data set, we've kind of learned all that we can, and we start to do some overfitting. So the train loss keeps going down, but validation loss doesn't keep going down. So we should probably stop our training after about 20 epochs. So now to do some analysis about how that looks as a function of the number of different hidden units, let's save that result to this this data set here. I'm calling it metrics wide. So here, this data table is going to be just, one row for each of the epoch and one column for each of these metrics that we're plotting here. And what I'm going to do is I'm going to save that in this. So here we have a for loop over a variable called hidden units I, and then we create that variable called hidden units, which is 1024 in this case. So if we do, let's use that as the index for our list here. Paste hidden units. What that's going to do is it's going to save the result in this units metrics list. The result is going to be this data table where we have the number of hidden units along with these different metrics, right? So units metrics list is not found. Let's initialize that as the empty list first. And then now we have, units metrics list. Well, this is a list. So far it's only got one thing, but what we're going to do is we're going to add a bunch of data tables to this that all look about the same, but they're going to have the different results for the different numbers of hidden units. All right, so so here's what we're going to do. To save computation time, we can use this this pattern again. Well, first, before that, let's just set another one running. Hidden units I equals 9. So here in this case, we're going to be running one with 512 hidden units. So let's just run that one in the background while we're revising this code. So yeah, to kind of optimize this code, hidden units vec, we can say new hidden units new. So this will be the new parameters that we haven't computed yet. So we can define that as hidden units vec, where hidden units vec not in names units metrics list. So this is going to be the parameters that we haven't computed yet. So here are, after we've done the second result, we get another, train validation error, loss and accuracy curves. And now if we look at names units metrics list, now we see that there's two results, one for 1024 hidden units, one for 512 hidden units. If we look at this hidden units new now, that's going to be all of them except for those last two which we just computed. So here, before we refactor the code again, let me do some let me get another one going. Let's say hidden units I equals 8. Here, I'm gonna rerun that just to so we can have some computations going while we're doing the code refactoring. And so now what we can do is we can do for hidden units I, or hidden units I in seek along hidden units new. And then what we can do is hidden units gets hidden units new, hidden units I. And so what that's going to do is going to it's going to do an iteration for every new value instead of all of the values every time. So then it's going to save calculation time because we don't have to do the same thing twice. So here, let's do a print statement, print hidden units, so we can see what is the value that we're computing every time. And then let's execute that and see what it looks like. So, this is gonna take a little bit of time. It's going through all of these things. And so, like I've explained in previous screencasts, when you're waiting for a computation to take a while, what we can do is we can try to refactor the code to do a parallel computation. Here you can see the result that they print every time. Here in this case, you see the train and the validation. They're both going down all the time, so it means we haven't started to overfit yet. Anyway, so about the parallel refactoring, what we've seen before is that, if you want to compute all of these ones in parallel, what you would have to do is replace this for loop with a call to future.apply, future.apply. And here the first argument should be all of the values that you want to iterate over, and the second argument should be a function. And typically I give it this, it takes a value which is the same name as that first argument of the for loop there. I mean the iteration variable in the for loop. Now what we can do is we can save this as, say, units metrics list new. So this is going to be all of the results which are new to these values that we're just computing. So here the formatting is the indentation is a bit strange, so here I'm going to edit that with ESS set style, and I'm going to try the RStudio style so that we can get a little bit better indentation here. So here what we're going to do is we're going to put all of that in. So all of this is inside of this function now. And here, instead of, you know, writing an element of that list, what we do is we just return that list. So actually we just need to copy this code that we had there. And what that's going to do is it's going to basically, you know, run this function that we've defined for every value of this variable that we provide, and in parallel using whatever future backend that we declare. And so here we can do future plan multi-process, and what that's going to do is it's going to compute the result in a separate R process in the background. And so that's going to give us a list of data tables. And what we're going to do with that list is we want to write the results now to this units metrics list. Well, anyway, so we don't have to run that, because now if we look at units metrics list, we've computed all of the results that we wanted to compute using the initial for loop and just waiting for it to go. Then we go units metrics, and what this is a data table with all of the train and validation error curves for all of the different model sizes, all the different numbers of hidden units. So, you know, what we can do now is we can maybe take a look at what all of these curves look like. So let's take a look at so yeah, I guess we can do that in a separate screencast, because we've already seen quite a lot of stuff in this one. So let's take a pause now, and I'll do the visualization of all of these numbers in a separate screencast. Thanks.